Hello, computer science students. Welcome back for our second video about objects. In the first video, I kind of talked a little bit about constructors, um, how they actually create space and memory for an object, and then how you create variables to point that memory so that you can call methods. In this video, I'm going to talk a little bit more about actually calling methods, what it does, how they work, and so we're going to kind of again revisit this code and work with it some more. And so to dive in, let me highlight where our method calls are in this code. So line 8 here, we have a method call to our scanner object to read in the next integer. And then as written right now, we have two more method calls, which are lines 14 and 15, where we're using our player variables to call the getName method and be able to print them out. So the key with methods, when you create an object, they have data. They store this data. But just storing the information would not be helpful unless we had ways to access it or change it or whatever. And so that's what methods let us do. Right? Objects have data that's stored somewhere and methods that allow us to either access or manipulate that data. And so for the example in our game here, we have the data for two players, their names, their height, and their number of apples. And so we can access that data. This is called an accessor method, often called getters, because they usually start with the word get. And they get information so that we can print it and access it. And so in this case, we're getting the names of our players. Another type of method that's very common when working with objects is called a mutator. This is something that changes or mutates the information within an object. So one example of a mutator in our player class, I can flip back over and show you real quick. This getName is an accessor. It returns information about the class. One mutator, we'll do kind of an interesting one. Let's use the eat apples method. This is a mutator. So this method will take in some double, which is the number of apples that we want our user to eat, and it will subtract that from the total number of apples they have. So mutators just change information. Let's say that Deshaun Watson was hungry. So player 1 eats 2.3 apples. I don't know. So you'll notice that there's a difference here. With my accessors, like getName, I have that inside a print statement. I could do other things with it, but because we're accessing data, you want to do something with that data. You might want to just print it out, like we did down here, or you might want to save it in a variable, like I could do string player1 name equals player1.getName, right? So I could read their name and store it in a string and use that string later. I could, change things or reference things or do things. But it's important that when we have an accessor, when we get information from our class, that we're either printing it or storing it in a variable so we can do things with it. However, with mutators, where we are changing data within our class, we don't necessarily need to print it. Right? This just does its job. It makes a player eat apples. And it's important that when we write our classes, we try to make the methods do our one really specific task. Reading apples and printing them and returning them is stacking too much information for one job. And so instead what you might do is kind of perform that yourself. So let's do system.out.println, player1.get num apples, and then they would eat them, and then we could print again how many apples they have. So I'm using an accessor to get their number of apples, a mutator to change how many apples they have because they ate some, and then an accessor to see how many apples they have now. So if I run this program, I still have to type in the first part of it here, but then we'll see that Deshaun had 82.6 apples, and then he ate 2.3 of them and now has 80.3. And so when we run the rest of our examples, I'm going to get rid of this scanner so that we can run them quickly. But you can see that we called one method an accessor to print information. We called another method a mutator to change information. And then we have our third method call the same accessor again to print it out. One other quick little highlight here is that we could have player2.getNumApples. And because our objects are two separate pieces of data, two separate spots in memory where information is stored, when you change one, it does not change the other. So while Deshaun went from 82.6 apples to 80.3, my player, the Ryan Matfeld player, still has 17.1. Right, so this is another key concept of objects. When you create them, they are their own unique space in memory, their own unique data. And then, even if you change data in one player, it does not affect the other player. And so this is really good for a lot of different applications where you want to be able to create multiple things that behave the same way, store the same type of data, but their data may change differently, right? Different players will have different amounts of health or ages or height or number of apples or whatever. And so using different objects to represent them allows us to kind of organize and structure this code better. And so, in some cases, we'll have methods that require specific input to change the number of apples, and in some cases, we won't. We could, for example, have a mutator that has us throw an apple. So a player threw an apple at another player. This method does not require input because it just throws a single apple. These requirements for what you need for inputs for our methods and what our methods do are all defined by whoever wrote the class. Sometimes you did, so you'll know what the methods do, and sometimes not. And so our next video will touch on API, or programming interfaces, application programming interfaces, where we want to be able to see how the class is written, and these summarize what information methods or constructors need and what methods do. So our next video will talk about API, and that will allow us to write more effective programs and use objects more effectively as well. So thank you for watching, and if you have any questions, please let me know. See you guys soon.